everyone, myself Sravanthi, working as the Assistant Professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today my topic is recognition of tokens. So here we are going to discuss what is a token and how to recognize the tokens and what are the examples that comes under this recognition of tokens with transition diagrams. So here first we will be discussing what is a token and how to identify the tokens, all those. So lexical analyzer, so basically these tokens are generated. Actually there are 6 phases in our phases of a compiler. In the compiler we have 6 phases are there. The first phase we will be having is the lexical analyzer, and the second phase we will be having is the syntax analyzer. The third phase is semantic analyzer, and fourth phase is intermediate code generator. Fifth phase is code optimizer, and sixth phase is the code generator. So these are the 6 phases of a compiler. So here we are going to discuss here about the lexical analyzer. So what it does? So the lexical analyzer reads the source program. The source program is given as a pure high-level language. This pure high-level language is given as an input to the lexical analyzer. So the lexical analyzer scans the source program character by character and produces the stream of tokens. It generates the stream of tokens. The tokens can be the here identifiers or keywords or punctuation marks or the symbols. All those comes under the tokens. So here the token is nothing but here the smallest meaningful unit. So that can be recognized by the compiler. So here a token is consisting of 2 components are there. So token name and attribute value. So just now I told the token name can be here we are going to convert the source program into a tokens. I am telling stream of tokens. The tokens can be here identifier or number or keyword or constant or literals or punctuation marks. Anything can be an token. So that tokens will be representing it in the form of a anchor tags, that is with token name and attribute value. So the token name tells us that it is an identifier that should be stored in the symbol table. There will be a symbol table in the phases of a compiler. So the symbol table, there will be a connection for the symbol table for all the 6 phases of a compiler. So the token name, for example, let me take the token name is an identifier ID. So here in the symbol table, it will allot the ID 1. There will be a space is allotted with an attribute value. So the attribute value tells us that so it is the address, like it is a pointer variable to the symbol entry. Suppose this ID 1 is stored at one address. So nothing but all the details of these token name, like the value or the scope of this variable, everything will be stored in this address, nothing but in the point attribute value. So that is the reason here this is connected to the symbol table. It verifies whether the token is a valid identifier or not. If the token is a valid identifier, then it will be placed in the symbol table at some pointer variable, at some address. So that address is nothing but we'll be pointing it as attribute values. Here we will be having the token names like operators and operators equal to plus, minus, all these operators or special symbols. There won't be any attribute value, nothing but there won't be any space allocated in the symbol table. Only for the token name will be allotting the space. So this is nothing but here the tokens. So here we are going to scan the source program, and it is going to generate the tokens, and that tokens we are going to give to the syntax analyzer. So the syntax analyzer takes these stream of tokens as an input and it generates the output as a parse tree. So let us see, these are few examples here. So tokens are generally specified with the help of regular expressions. Here we are going to generate the tokens. So tokens are nothing but here it will be generating the patterns it in the form of a regular expression. So to represent the regular expressions, we use the transition diagrams. So to represent these regular expressions, we are going to use the transition diagrams. So there are few examples that comes under these tokens. Nothing but here we are going to recognize the identifiers, recognition of delimiters, recognition of relational operators, recognition of keywords such as if, else, for loop or while. All these comes under the keywords, and recognition of numbers. The numbers can be integers or floating point or exponential values. So all these are nothing but the few examples of these tokens. So here we are going to scan the source program and it generates the tokens character by character. It reads the source program and it generates the tokens. That tokens we are going to specify with the help of a regular expressions. To represent these regular expressions, we need the transition diagrams. So here these are the different types of tokens we have here. So let us go for the first one, that is nothing but recognition of delimiter. So delimiter is nothing but here it can be any separators, or it can be brackets, or it can be white spaces or tab spaces or new lines, or it can be say literals like double quotes or single quote. All these things are comes under the delimiters. For example, let me write here A B semicolon, or A B literal single literal, or A B open brace. So nothing but here all these are nothing but the delimiters. So delimiters, the delimiters can be here to separate the program from the different tokens. It is used to separate different tokens in a program. Even there are delimiters in a program, even the program will execute, even it won't give any error, but still we will be removing those all the delimiters. So here the punctuation marks or separators are one of the delimiters. Brackets are also delimiters. White spaces like space or tab or new line, and quotations like single literal or char literals. So these all are nothing but the literals, delimiters. So here the recognition of delimiters in the lexical analysis, where the lexical analyzer scans or identifies and that separates tokens in source code. So the source code is given as an input to the lexical analyzer. So the lexical analyzer scans the source program and it generates the tokens. When it is generating the tokens, it eliminates all these tab spaces or new line characters or comment lines or literals or spaces or separators. All these things will be removed and it will generate the tokens. Nothing but it separates tokens in a source code. So here the regular expression for these delimiter will be, so here WS is nothing but the word space. Suppose this is my first string, I am having first string. Let me write here, this is my first string I have written, and I have left few spaces and I have written here second string. So nothing but these are the word spaces or all the spaces or new lines, all this. So even these are there, the program will execute, but still we will be removing all those. So nothing but WS is pointing to the word space equal to delimiter or delimiter whole star. So the regular expression for this is nothing but there can be one delimiter or it can be more than one delimiter. So how I can write that regular expression? So the regular expression I can write is delimiter. Delimiter is nothing but it is pointing to one, that can be the white space or punctuation mark or quotations or brackets, and I can have more than one delimiter also. So represent more than one delimiter, I am writing here star. So star is pointing to zero or more occurrences of these delimiters. So this is my regular expression. So when I am converting this regular expression into a transition diagram, so here the start state, let me take the state number as anything. So the single circle represents the start states. So we will be writing the state names inside this circle. If the state is having a starting arrow symbol, that is pointing to the starting state, and the circle is there, it is bonded with two circles, then it is pointing to the final state. And for each state there will be an edge, it points to the to move from one state to the another state. So this is my regular expression, and this is the transition diagram for this one. So first I have delimiter. So just from one state to another state I am moving with a delimiter, and here I am having delimiter whole star. So delimiter whole star is nothing but I can have more 0 delimiters or more delimiters. So that we are going to represent it with a whole star delimiter. So let me take here example, this semicolon. So it comes here start state and 22, and it comes here final state. So it is nothing but the one delimiter is accepted. If I have delimiter or space, so this is also accepted. So it comes here, the first semicolon will be read, then after I have space, so it comes here self loop. So self loop is nothing but 0 or more. Anytime, so if I am having space or new line, open brackets, so all these things will be read by using this delimiter. Nothing but star is pointing to 0 or more occurrences. So this is nothing but recognition of delimiter. So the next one is recognition of identifiers. So identifier is nothing but a name given to entities such as variables or functions or classes or labels, anything. So that is nothing but the name which we give it. So that is we are going to call it as a identifier. So the rules for identifiers are how an identifier should be. An identifier should start with a letter or an underscore. It is generally we will follow in C. In C there can be an underscore, but coming to the Pascal there is no symbol also will be allowed. No symbols are allowed in Pascal like underscore, but coming to here in C the underscore will be allowed. So begin with a letter. The identifier should start with a letter, or and it can start with an underscore. It can be followed by any combinations of digits like AB1. It can be followed AB12. It can be followed. Nothing but it should start with digits. It should start with letter, or it can start with underscore. But it can be followed with any number of digits, combination of digits or underscores. So cannot contain any special characters. In an identifier, when we declare an identifier, in that identifier there should not be any special characters like at the rate or hash or dollar or ampersand or some spaces that won't be allowed. So instead of that spaces, we can point the underscore also. So cannot be reserved keywords. The keywords cannot be our identifiers. So here the identifier should start with a letter, or it can start with an underscore, and it can be followed with a number of digits or underscores, but it cannot contain any special characters or keywords also. Reserved keywords like if, while, else, for, all these keywords cannot be used as a identifier. So the regular expression for an identifier, how we can write the regular expression for this identifier? So the letters can be either small a to z or capital A to z. It's a combination of capital and small letters, and the digits should be, it should have 0 to 9 digits. It should have 0 to 9 digits. So the identifier, so how we can identify the identifier? It should start with letter, letter or digit. It can start with letter or digit. So nothing but it starts with letter, and it should be followed by letter or digit. So nothing but here it is a zero occurrences. Star is nothing but pointing to zero or more occurrences. Zero or more occurrences. It starts with letter and it will be followed by letter or digit. So A, it can be accepted. AB, it can be accepted. A1, it is also accepted. Why? Because the first one I am having a letter. So yes, A is a letter. It is nothing but letter or digit is nothing but zero occurrences. So it will be accepted. Next AB, letter, and I am having the next one is the next character is B. So here letter or digit. I am taking letter. So B, it is accepted. A1, so letter, first one I am having is the A. A is a letter. So it is accepted. So the next character is 1. So 1 is nothing but digit. So this is also accepted. I can have A12. Is it accepted? Yes. Letter, first letter I am having is A. Letter, it is accepted. Next 1 is there. So 1 is nothing but it's a digit. So digit is accepted. The next again I am having 2. 2 is also digit. So nothing but this star is pointing to 0 or more occurrences. So this is recognition of identifiers. Let us look an example over here. So with a transition diagram. So transition diagram for AB12. So how I am going to write here the transition diagram. So let us draw the transition file diagram for this one. So what I am going to have the transition diagram for this regular expression. So let me have, this is my start state. Start state, let me take it as 1. So what I am going to have here, letter. The next I am having 2. So it can be a letter or digit. Letter or digit. Letter or digit. So this is nothing but my regular transition diagram for the identifiers. So see here. So let us look an example. Transition diagram for AB12. AB12. So what I am going to have, the first one is letter. So letter, and the next, so what is the regular expression for this transition? Letter or digit whole star. Letter or digit whole star. So this is the regular expression for this identifier. So how I can draw the transition diagram for it? So letter, let me, this is my starting state. So start state will indicate with an arrow. So here the first one I am having is letter. At least there should be one letter. The next second state, that is nothing but my final state, and I can have letter or digit. It's a combination of letters or it's a combination of digits. Letter and digit also it can be there. So letter or digit. So star is pointing to 0 or more occurrences. Star is pointing to 0 or more occurrences. So see here, AB12. AB12. So the first letter I am having is letter. So from 0 state, it is moving to the first state. So AB12. So from first I have an input is 0. Sorry, A is the input. A is the input. It comes here start state. So A is the input. So it moves from 0 state to 1 state. Now again I have B. So B is nothing but what I have here. I can read letter or digit. So it is moving to the 1 state. And next I have is 1. So 1 is nothing but it's a digit. There is a self loop. So I can move itself nothing but 1. So again I have is 2. So nothing but 2. Again I am moving to the one step. So nothing but this is my final state. So I can read the transition diagram for the given identifier. So let us look one more transition diagram for an example, sum semicolon. So let us take this is an in C example. So here I have sum is nothing but my identifier, and the semicolon is nothing but it is pointing to the delimiter. It is pointing to the delimiter. So what I can do here is for this extension, I'm going to add the delimiter. There can be one delimiter we can have in an identifier. So nothing but sum. S is there. So S is nothing but it is moving from 0 state to 1 state. 0 state to 1 state it is moving with S, and the next character I am having is U. U is nothing but itself I am having. So from one state it is moving to the one state itself. The next one I am having is M. So nothing but from one itself it is going M, and the next I have is semicolon. So semicolon is nothing but it's a delimiter. So it is moving to the second state. It is moving to the second state. So this is nothing but the transition diagram for the identifier. So the next one is recognition of relational operators. So there are different relational operators are there. So these relational operators are used to compare two values and to find out whether it is true or false, or whether to go to the for loop to execute the program or not. So for that we will be using these relational operators to compare the two values whether it is true or false. So it commonly includes less than or equal to, greater than or equal to, double equal to, and not equal to. So nothing but these are the commonly used relational operators. So let us draw the transition diagram for these relational operators. So how we are going to draw this? So the first one I am having is less than, less than. So let me take my starting state. 0 is my starting state, and the next what I am having is the first one I am having is less than, less than. So let me go for the second one, less than. So nothing but first it is moving to the first state. So the next what I have is less than, equal to, equal to. Next I am moving to the second state. I have completed reading this one. So it will be my final state. It will be my final state. So the next one what I have here, 0, and it is less than. So from here where I can go, it is nothing but if after less than some other symbols are there, other symbols. So then I can move to this third state. I can move to the third state. So the next one I am having is here 0, less than. These two things are completed. So the next one I have is greater than. So greater than, and 3 is completed. So the next one I am taking it as fourth state, greater than or equal to. Then it is moving to the fifth state, and it is my final state. And next I have greater than. So if it is greater than and some other symbols, then I can move to the sixth state. Other symbols, then I can move to the sixth state. So the next one I am having is equal to. Equal to is nothing but here we are moving to the seventh state itself. It is moving to the seventh state. So here the next one we are having is the not equal to. So the not equal to thing I can show it with using the less than and greater than. Also I can show. I can show less than, greater than. These less than and greater than operator tells me that it is not equal to. I can represent like that, or I can place not eighth state and I can show it as not equal to. In this way also we can show this not equal to sign. So we can show this not equal to like this, or we can also show this not equal to. Both are pointing to this not equal to sign. See here. So for each one what we are writing here, less than, equal to. A token is consisting of token name and the attribute value. Token name and attribute value. So what it is returning here? It is returning relational operator and less than, equal to. So it is the sign is less than, equal to. So and it is less than and greater than. So this is pointing to the not equal to. We are writing it in as not equal to. Not equal to. Relational operator, comma, not equal to. And one more thing I am having, less than and some other symbol. So nothing but relational operator, less than. We are going to write it as relational operator and less than. So the next one what I have is here, greater than. So greater than, equal to, greater than, equal to. It returns relational operator. Relope is nothing but relational operator, comma, greater than. This sign is greater. then equal to, greater than, equal to. The next one I'm having is greater than other symbol. So nothing but greater than, relational operator comma GT. So the next one I'm having is double equal to. So double equal to is nothing but, see here, return relational operator equal to, equal to. So here these are the nothing but, this is the way we can represent the transition diagram for the relational operators, and we can reach the final state. So the next one is recognition of keywords. So a keyword is nothing but, it is the reserved word in the programming language that has some fixed meaning. So here while we use the identifiers, keywords can be like if, else, for, or while, do, while, all these are nothing but the keywords we use here. So the keywords cannot be used as a identifier also. So here let me draw the transition diagram for these keywords. So this is my starting state. I want to reach this if, I, first character, then one AF. It is moving to the final state. So the next I have else, E, ELSE, else. So the next one I have for, F7 O R, for. So the next I have while. So I can draw this while, W. Each character, when it occurs first character, it moves to the next state. When it finds the next character, it moves to the next state. In the same way, it finds the final state. It reaches the final state. W, next state is moving to the 10, and H, it is moving to the 11. I is moving to 12. L, it is moving to 13. E, it is moving to 14. So while is completed, it is nothing but it's in the 14th state. So the same way int also. I have I, then I can also write here return. So return also I can write R 15 state and 16, 17, R E T U R N. So this is my final state. So I can write here int I. So 1 it is coming, n it is can be some 20, it can be 21, and t it can be 23. So it is reaching to the final state. So in this way we can write the transition diagram for these keywords, recognition of keywords. The keywords cannot be our identifiers. Why? Because the identifier starts with a letter or underscore, and it can be followed with any combinations of letters or digits, but it should not be any reserved keywords, and it cannot be any special symbols also. So the next one is recognition of numbers. So the numbers can be, it means nothing but detecting the known tokens in the source code that represents values like integers or floating point numbers. It can be integer numbers or it can be floating point numbers. So integer numbers are nothing but it will be a combination of 0 to 9 numbers. So here 123, this is one integer number that can be a combination of 0 to 9 numbers, any numbers. So 4, 5, 6, 7, yes, that is a number, and 0, it is also a number. So coming to the next one is floating point number. So the floating point number is nothing but there will be a decimal part like it is represented with a dot, and a fractional part digits also we can have like 123.4. This is nothing but the integer part, and this is nothing but the decimal part. The decimal part is represented with point, and then after we will be having some fractional part. So 3.14 or 0.5, 1 to 3.456. So these are nothing but some floating point numbers. The next one is exponential notation. So the exponential notation can be having an integer or floating point number, some followed by exponent, like we will be representing in between capital E or small e. It tells us that it is an exponential notation. So there can be an optional signs also. It can be positive sign or negative sign or no sign. And another sequence of digits like we will be having 2.10. There is no sign in between, plus or minus. Here I am having some minus sign. Here I am having plus sign. So this is nothing but the exponential notation. So here the numbers can be represented by using integers or floating point numbers. Integers can be represented from the numbers 0 to 9, and coming to the floating point numbers, a floating point number will be having a decimal part and the fractional part numbers can also be there. Coming to the exponential notation, an integer or a floating point number can be followed by a exponent like e or capital E or small e, with some signs like plus or minus signs can be placed here with the digits. Suppose 0 2 point e or 2.35 e minus. So nothing but some signs we can also be produced like e minus or p plus or no sign. So these are the way we can recognize the numbers. So the regular expressions for the digits. So how the regular expression can be written for the digits? So the digits can be I just know we discussed the digits are 0 to 9 numbers. What I can represent is 1. So 1 is nothing but I can write single digit. Single digit I can write. If I have two numbers 1 2, so what I should write here? Digit whole star. So nothing but here digit is nothing but one occurrence, digit star is nothing but 0 or more occurrences. So here this is nothing but in this way I can represent the digits. If I have 1 2 3 numbers, so digit, the first one is digit it is, and the next one is 2, it reads here, and again 3, it reads here. So nothing but here 0 or more occurrences of digits can be read. So I can have 4 5 6, yes, these things can be read. So compulsory there should be one digit, so that is nothing but digits. Okay, so that's the reason I'm writing one time digit and digit whole star. So this is nothing but 0 or more occurrences, but this is mandatory, we will be using. So that is the reason digits is pointing to digit or digit whole star. So the next one is numbers. So the numbers. So how the numbers can be represented? So here we are having numbers are of fractions, nothing but floating point numbers, and also we have exponential numbers. How we are going to represent those exponential numbers or fractional floating point numbers? So here the floating point numbers can be represented as 123 point some 45, 123.45. So how we can write it? So digit, so these 123 I'm writing it as digit or digit whole star. I have dot is nothing but this floating point number I'm pointing. Then I can have here digit, digit star, digit star I can have. See here I can have 123 d1. I can have whole star is nothing but there can be one or more occurrences, and I can have here dot, dot is pointing over here, and the next I can have digit and digit whole star, digit whole star. So nothing but 4 and 4 5 5 6 7 anything 5 6 7. So these type of floating numbers can be read this one. So let us write this digit of digit whole star with one name, that is nothing but digits, and I'm reusing that here itself. So that how I can write is nothing but digits, digits dot digits, digits dot digits. So digits is nothing but it is pointing to digit of digit star, and digits is nothing but digit dot digit star. So in the dot is nothing but it is to represent the floating point values. To represent the floating point values, we are going to use this one. So the next one we are having is exponential values. So to read these exponential values. So how we are going to read these exponential value? Exponential values, what we are going to have is, let us take here 123 point E. 123 point E. So how I can write that one? So let me write that one. 123 point E. So how we are going to write that one? So here I have digit, digit dot digits, dot digits. The next I can have is E. E is nothing but it is representing exponential. I may have sometimes 123 point E minus, we have seen here E minus y or E plus or E10. So to represent that, we are going to use here plus minus, plus minus. And the next I can have after these E minus some 1 5 3 2 so on. So I can have here digits. I can have here digits. So here digit, digit dots, nothing but 123 it reads, 0.45 it reads, the next E it is reading. So plus some digits I am going to read like 2 3, are the digits I'm going to read. So in this way, these expression can be read over here. So here I want to read 123 expression or 123 number. So nothing but here what we are going to use here is nothing but star is used, question mark is used. So this question mark is pointing to 0 or 1 occurrences. This is pointing to 0 or 1 occurrence. Nothing but here I can use this one or not. I can use or not. So that is nothing but 0 or 1 occurrence. Here also this one, as in some expressions like 123.45, in this expression I don't have exponential values. So at that time this is nothing but pointing to 0 or 1 occurrences. Suppose I may have here E but I don't have plus. So nothing but 123.4 E10. So nothing but at that time I don't have this plus or minus. So that is the reason I am going to use here question mark, that is nothing but 0 or 1 occurrence. Here digit plus is nothing but it should have 1 or more occurrences. Here also it is nothing but 1 or more occurrences. So here this is I am replacing it with 0 or more occurrences. So the regular expression for numbers is nothing but digit plus dot digit plus question mark E of plus minus question mark digit plus question mark. So question mark is pointing to it can read 0 or 1 occurrences. 0 or 1 occurrences. When we write the regular expression or when we draw the transition diagram, we need to check all the possible cases and we need to draw this transition diagram. Let us see this one. Digit plus dot digit plus question mark E plus minus question mark digit plus question mark. So the question mark is pointing to 0 or 1 occurrence. So here I want to read the expression 123. So before reading the expression, let me draw the transition diagram for this regular expression. So the transition diagram for this regular expression, it accepts floating point values, it accepts integers, and it accepts the exponential values. So first let me draw this one. So here the states names can be anything. I can take 1, 2, 3 or 12. Any number you can take the state names. Here I have taken 12, 13 for my comfortable. So let me draw here. 0 is my state. Let me draw 0 state. And first I am having is digit. So digit. And the next it is moving to the first state. So nothing but digit plus is nothing but it is pointing to digit of digit star. So it is pointing to digit. The next what I have here, dot. So the next it is moving to second state, dot, and next I am having is digit, third state, and I am having digit star. Digit star is nothing but self loop. The next I have here is E, nothing but exponential value. Fourth state it is moving. There can be plus or minus, plus or minus. Here I am having. Then it is moving to fifth state. Again I am having here is digit plus is nothing but what I can write here, digit, sixth state, and I have digit. There can be some other things also. So let me write here some other symbols or other values I will be having. So that is nothing but it is seventh state. It is the seventh state. So here it accepts all the values. Let me check whether what type of number it is accepting. 123 point E plus some 45. Let me check. This is the value it is accepting or not. 123.2 E some I am writing. So first one I am having is digit. So 0 to 1 state it is coming. So first digit is read. So the next one I have 2 is nothing but it's a self loop. 2 is read. And next 3 is read. Next dot. So it is moving from first state to second state. The next I have digit. So from second state to third state it is moving. The next I am having E. E is nothing but from third state to fourth state it is moving. Then I have plus, either plus or minus. So I am taking plus and it is moving to the fifth state. So the next I have 4. 4 is a digit. It is reading 4 digit. And the next 5 is there. 5 digit is read and it is moving to the 7. Nothing but that is moved to the final state. So this is the expression, it is accepted. Let us assume that I have only one expression, that is nothing but 123. 123 is the value I am having. So whether which state it is moving, it should reach the final state when I complete reading this number. When I complete reading this number, it should reach the final state. So here digit and digit. So I'm not going to read this dot, digit, all those things I am not reading. So nothing but here, this should be my final state. Now if I keep 8 as my final state, see here, 1 digit it reads and 2 is there, it reads the self loop, and the next 3 it moves to the self loop and it comes over here. That is nothing but, let me write here, other, and it is coming to the final state. And it is coming to the final state. So this is nothing but the, it accepts 123 state. 123. So let me take here one more thing here, 123 E plus 10. Let me take here E plus 10. So what it is doing? It's from digit, it is coming here and it is reading the digit, and it is reading the digit from 1, it should move to the E. It should move to the plus or minus. From 1, I'm not reading dot and digits. I'm not reading dot and digits. I need to move from first state to the fourth state. So why? Because I need to read the next one I'm having is, next occurrence I'm having is plus or minus E. And the next I have plus or minus. So plus, the next digit 1 is read, the next 10 is read. So it is completing my final state. It is completing my final state. So this is the next value, it is read. So the next values we can also have is 123, suppose 45, floating point value 123.45, whether it is reaching the final state or not. So the first 0 to 1 state, the first character is read. So the next one 22, the self loop 2 is completed. So the next 3 is also completed, and the next point it is moving from first state to second state, and the next 4 I am having from 2 to 3 it is coming, and next 5 it is moving to the third state. So from the third state it is now moving to the 4, 5, 6. So let me, it will be ending over here, that is nothing but 9. So let me take these as some other symbols. Other symbols. So here this is nothing but, here we'll be having these other states we'll be having. So here how we can identify whether these are the values it reads. So here it is having 0 or 1 occurrences. See here 0 or 1 occurrences. Let me take here 0 and let me take here 0. So these both are pointing to 0 or 1 occurrences. So nothing but how many possibilities I will be getting? 4 possibilities I will be getting. Let me take these 2 as zeros. Let me take 0 and 1. 1, 0, 1, 1. So 1, 1 is nothing but, this is the whole expression it reads. Nothing but this whole regular expression it reaches and reaches the final state. And the next one is 0, 0 is nothing but, it reads only this one. Nothing but 123 is read. 123 will be reading. So I got the final state. And the next one I am having is 1, 0. 1, 0 is nothing but, it reads only till here. And nothing but 123.45. 123.45, these type of values it will read, and it is reaching my final state. So nothing but, that is nothing but, here 1, 0 is read, 0 is 0 is completed, and 0, 1. 0, 1 is nothing but 123 E plus 10. So 123 E plus 10 it is reaching. So the next one is 0, 1. 0, 1 is nothing but, it should not read this floating point value directly, it should read these values. So the next one is 1, 0. 1, 0 is nothing but, what I need to read here, these values will not be considered. E plus minus digit should not be considered. 1, 0 is nothing but, this E plus minus digit should not be considered. So what I will be getting here, 123.45 I can read here. So the next one here, 0, 1 is nothing but, I should not read this point, nothing but 123 E plus I need to read. So the next one I should read is 1, 1. 1, 1 is nothing but the whole expression I'm reading over here. So it is reading the whole expression. See here, digit, dot, digit, and it is coming E, and then I am having here. So sometimes what we are going to have, the expression as 123 E5 or 123 E10. So nothing but, I am not having plus or minus expressions. Here the plus or minus expressions sometimes may be or may not be. It's optional. Okay, positive, negative and normal values will also be taken. In that cases, what I need to do here, I should not reach this one. So nothing but it should come here digit dot digit and E, and it should reach this sixth state. It should reach with sixth state with some digit. So let me check whether it is working or not. I have written here 123 E10. So 123, first one is character, from 0 to 1 state it is coming. So 2 is nothing but from 1 itself it is lying. The next one 3 is a character digit, it is lying in the same state. The next one I am having is E is there. So it comes from here to here, nothing but from first state to it may come to the fourth state. Fourth state it is reaching, and the next I have 1. So nothing but from 4 to 6th state it is moving, and 0 I am having. 0 is nothing but self loop and other symbols, and it is reaching the final state. I can also have 123.45E10. So these also can be read. Here I am moving from 1 to 4. In that case, I will be reading all those. I will be skipping these states. So this is nothing but the recognition of numbers. Nothing but here how we are going to scan the digits. So these are the topics we have discussed here. So here what is a token and what are the examples that comes under token, like recognition of identifiers, recognition of keywords, recognition of delimiters, recognition of numbers. All these things we have discussed with an example. Nothing but we are going to construct the regular expression for each one, and for each one we are going to draw this transition diagram. So why? Because this lexical analyzer will give as an input nothing but the lexemes or tokens. Nothing but it checks the patterns. So based on these patterns, it generates the finite automata, and these finite automata will be given as a input to the syntax analyzer. So this is about the recognition of tokens. Thank you.